The next factor we are going to look at is pressure, and pressure applies to gaseous reactants only. So gas has weak intermolecular forces, and then they can be compressed. So when I decrease the volume, I'm increasing pressure. Solid and liquid, the particles are close together. I cannot compress, so there's no pressure involved. Okay, increasing the pressure of a gas is the same as increasing the concentration. Okay, how do we explain it out? At higher pressure, there is smaller volume. So there's more particles per unit volume. So let's use this picture. Right, when I increase the pressure, the volume decreases. So this one over here is actually almost the same as here. This part over here, I only got 1, 2, 3, 4, 5, 6 particles in this volume, the red part below the red part. Right, but over here, this picture, I have 1, 2, 3, 4, 5, 6, 7, 8, definitely a lot more than the left side, which is the low pressure. Okay, so this part is increased pressure, more particles per unit volume. This increase the frequency of collision, increase the frequency of effective collision, increase the speed of reaction. Same thing word for word, we have to write it out properly. Okay, next factor that we are going to look at is temperature. And temperature will apply to all reactions. Okay, so distribution of energy of particles. Okay, kinetic particle theory tells me all these particles are in constant random motion. Solid, liquid, gas, constant random motion. The amount of energy all particles have in the system will follow a bell curve. So this is a bell curve. Bell curve, we also say this is a normal curve. Okay, so example, if I have 100 students, some students will score 0. Some students score full marks. Okay, and then the bulk of the students will be around here, the average, say 40 to 60. Okay, this is the bell curve, and all systems, all right, all distributions will follow this kind of graph. Okay, so if I relate this to energy, some particles will have very low, some particles will have super high, but bulk of the particles will have energy that's around this level. Okay, so what's going to happen? Then we learn, right, that all chemical reactions will have what we call the activation energy. So if I put the activation energy over here, in a normal bell curve, this is your first bell curve over here. Okay, when will reaction proceed? These particles, the shaded blue area, right? These particles will have energy higher than activation energy. And only this blue shaded area, the reaction will proceed. Okay, what happens is when I heat the system or when I heat the reagents, okay, right, your particles gain heat energy and this is converted to kinetic energy. So over here, right, there are more particles. They will become fatter and broader. This picture or this graph that is in green. Okay, after I heat it, there will be more particles that has energy higher than the activation energy, which is this green part that I'm going to shape. Okay, repeat myself. Okay, a normal graph will look like the red ones, the first red one. After I heat it, right, it will turn from the red to the green. Why? These particles, they gain energy, so they become broader and fatter. They move faster, right? So they become broader and fatter. Okay, so if my activation energy is here, blue ones are from the before heating. Okay, and then the green ones are after heating, and these green ones, they will have energy higher than the activation energy. So from this graph, we can see and explain it out. If I raise the temperature, the particles will gain more kinetic energy. And then what happened? The proportion of particles that possesses energy more than activation energy increase. The green part increases. So this increases the frequency of collision, increases the frequency of effective collision, increasing the speed of reaction. Okay, same thing if it's a temperature. If I'm using temperature to explain why does increased temperature increase the speed of reaction, this explanation is what I write. Okay, the key point is over here, those that I highlight in yellow. So good to know, a rise in temperature of 10 degrees, this one will usually double the rate of reaction.